everyone coming for this forum. My name is Jialiang Qian. I'm from Donghua University. I'm currently the Vice President of the university. We will have 5 speakers today, but before we start it, we would like to welcome the project PI, the main PI of this big project called Transdisciplinary Science, Humanity, and the Social Science. This project, the manager of this project, Professor Chen Zhuting, to speak a few words.
Thank you, Vice President Chen. I'm Zhuting Chen, Professor of Chemistry in National Taiwan University. In the meantime, indeed, I am the PI of we call it short SHS project. SHS project from here, you can see SHS represents society, humanity, and science. Exactly fit your program today. We try to envision higher education. Of course, not only just sustain the needs of enterprise, because sustain the needs of enterprise is one of the current problems in the society. So we consider any of these kind of problems, either local or global, they turned out to be complex, which needs all the technical people, technology, science, engineering, and society and humanity work together in the society, in the local society and the international society. That's exactly what we mean as SHS. So we put society as the first ace, science and technology as the last ace, okay, and humanity certainly in between. Another key words, exactly as Vice President Chen mentioned, is transdisciplinary. We think that may be the future trend or current trend for higher education. But right now, I think my main role today is to welcome our distinguished professors, Professor Straub, Professor Gregory, and President Lin and President Huang, all together. We have relatively fewer audience. Apparently, I think I had some misconnection with the program. But anyhow, I hope you can enjoy your stay today in National Taiwan University, and I guess you already had a very good stay in Taiwan. So welcome you all, and have a very good success in today's program. Thank you very much.
I'm the head of Department of Arts Creative Industry, National Donghua University. It's my privilege to present today's program. We celebrate academic in this kind of forum, and we celebrate creativity and innovation in the forum as well. Hope you have good time in today's short but very good program, the content of program. So let me introduce our invited speaker. First speaker, let me introduce Professor Dr.Straub. Professor Dr.Straub actually is a very distinguished professor. He teaches information system at Georgia State University. And his research focuses on management, computer information security. That's very important right now in the global sense. And the legal and ethical implications. That's also very important concern with concern of ethical issues. And the technological innovation, IT outsourcing, and the system integration. And also electronic commerce. It's lots going on, right? Actually, I think Damar must have something more than this. After a few days studying with Damar, he's a very knowledgeable scholar. He also been consultant for many Fortune and many enterprise for so many years. and even have some personal relationship with to consult and mentor some other scholars in Taiwan as well. So it's our honor to invite Jaymar. Please welcome him. Our next invited speaker is Shirley Gregor. Shirley is professor of information system at Australian National University. That's very good university and very influential scholarly institution. Her research focuses on innovation and the strategic use of information technology. With many years working in the industry, actually has very precious knowledge and knowledge base and experience towards the link between the industry and academic institution. And he also likes to study the design research approach based on the human-computer interface issues. She had led several large research projects funded by the government as well, and also as a leader of this field in not only in Australia, in the continent, and also cross-country like South Asia and also Taiwan as well. So let's welcome Professor Shs Straub. Next speaker is President Charles Wang. Charles Wang got an MBA degree from the Walton School of Pennsylvania University. He's also the former chairman and the CEO of the Shs跨Corporation. Now, President Huang is a director for many non-profit and profit-seeking organizations, and he's very actively involved in the non-commercial activity to assist the government planning ecological balance. That's really, really key issue in terms of the situation in Taiwan and the environmental friendly and very green conceptual development plan. So President Wang, we can see and understand he has been involved himself devoted himself into this very crucial issues in Taiwan, and also must be very good implication with the global issues as well. Let's welcome Professor Huang. Let me introduce President Berlin. President Berlin is the president of the World Economic Society and director of the Institute of Public Policy as well. He studied focusing on the public policy and applied economics and international affairs. So he is really very key person in this forum as well. And provides consulting service to the government and also the private institution. You can see the range he devoted himself, and his advisory reviews and comments often published in terms of the public media. So actually, he's kind of shared his ideas in terms of the educational, public education as well. So let's welcome Berlin, President Berlin. Let me introduce Vice President Charles Chen. Charlie, we also he goes by Charlie. He's a professor in the Department of Physics in National Zhonghua University. His main research focuses in the spectroscopy and the microscopy. Huh? It's hard. Huh? You mentioned so many different terms. Well, I will skip that. His research group is among one of the leading team. Okay, this is very proud to know. One of the leading team and using very fancy terminology. Okay, in terms of his bio and medical application, especially in the cancer drug delivery. That's very good issue. Concerns of the health problem right now for many people. So in addition to his scientific research, he's dedicated in the general education as a physics and a scientist. It's kind of a little bit unusual from his main field. He dedicated himself to develop in the general education program in the campus and also in the community as well. His creativity, innovation also helped let him focus on another field of innovation education, innovation integration of students their field work into the higher education in terms of the community, the campus, and in Taiwan itself. Let's welcome Charlie. 跟各位同学、跟各位来宾介绍了一下，跟各位同学、跟各位老师介绍了今天的来宾其实今天我们虽然是人比较少，我特地用中文来讲，就是实际上这是一个非常难得的机会。这几位讲者呢，在礼拜二的时候，在我们东华大学的 campus 有了一场的讲座论坛然后这个讲座的论坛内容呢，非常非常的精彩。我们的学生当场有100多位每一位同学都觉得非常的有兴趣，所有的 topic 跟我们的 issue 在论坛里面做的讨论。今天虽然我们的同学们并没有那么的多，不过我想说大家可以更轻松的来看待我们现在面对的一个非常重要的议题。这个议题呢，就是希望能够让我们的高等的教育能够真正福音学生未来学习以及贡献给这个社会他所需要的一些职能或是专业的职能尤其是更重要是一个视野。所以今天让我们能够有比较轻松的心情，可是用一个比较积极的态度来看看我们是不是可以在这个论坛里面得到比较好的互相的一些分享。那我们let's welcome our guest speaker and invited speaker to on the stage. We started the first one. Okay. The first one let me introduce Dr.Straub. So you will be the first speaker. So please welcome Professor.
Good morning. I would like to start by thanking our hosts this week, Professor Chang, Professor Yao, and Professor Ali, who's up here. Thank you very much. It's been great to have you host us. I have a 10-minute presentation here having to do with the challenges to transdisciplinary research and teaching of students. And so I'll start by doing some definitional work, if you will. The way that I approached this was to go out into the web and to find a source where someone defined words that had to do with disciplinarity. And I found that in general, these terms like transdisciplinary, cross-disciplinary, interdisciplinary, they have to do with ways of thinking and ways of acting. So it has not only to do with the way people are thinking about a discipline, but also the way in which they act or behave when they're in a discipline. This is one way of looking at it. There are many others, if you will, but this would be a fivefold division of the whole notion of disciplinarity. The first one means that within a discipline, we have people with different knowledge sets. My view of higher education is that if we talk about disciplines, we would talk about individual faculties. Then we would talk about the ways in which those faculties would communicate their knowledge, transfer that knowledge to students, and stimulate students to think in that discipline. And then finally, there are structures that you might put in place that would encourage people to think in a discipline. Now, we're very familiar with interdisciplinary because many faculty and students have a major. So if your major is physics, that's the discipline that you're schooled in, and you respond to that discipline and its knowledge base. Now, if you get a group of people together, each one of them can be operating within their discipline, but when they're sharing ideas with each other, then they bring to bear their expertise on a common problem. But it's still multidisciplinary in the sense that you're not asking people to take on another way of thinking. So if I were a chemist and I were in a group with a physicist, I would expect Charlie to come up with the knowledge of the physics, and I would come up with the knowledge of chemistry, and we would bring it to bear on a common problem. Now, when we start to try to look at the world through the other person's perspective, I'm a chemist, I try to look at the world through what physicists have said, then we're engaged in what's called cross-disciplinarity. Up to this point, we see many, many examples of this, and then we finally see a few examples of interdisciplinary. And this is where I believe we integrate the knowledge of two different disciplines and we create a new field. For instance, we have people who belong to the field of biochemistry. That would be an example of this interdisciplinary. And then finally we have this new term, transdisciplinary. And I'll show you in a minute how graphically what this might look like, but it's ways of integrating all the knowledge of very, very different disciplines in such a fashion that you have a common framework. The only example I can think of this is that physicists, astronomers, chemists, many people in the natural sciences, biologists are trying to come up with a grand unified theory of the universe. That basically you look at the basic forces of the universe, you look at the way molecules are put together, and some of those are biological molecules, and you try to understand the place of human beings in the universe as a whole. That's the only example I can think of for transdisciplinarity. But it sort of looks like this. If you start at the first one here, we have intra, then we have a whole bunch of people together sharing their ideas. Then we have people getting closer because they're trying to think the way the other person thinks, or act the way the other person acts. And then finally, interdisciplinary. I'll give you some more examples of that in a minute. But then finally, transdisciplinary. The Venn diagram means that the circles are very much overlapping. Everyone is trying to have the same knowledge base by just expanding their horizons. Extremely difficult. The easiest one is the far left. The hardest one is the far right. Now, with respect to students and with respect to transdisciplinary curriculum and programs, my view is that you have to have interdisciplinary or transdisciplinary faculty, or you'll never have interdisciplinary or transdisciplinary students. Because the role of faculty in a higher education institution is not only to transmit knowledge, but also to give guidance to students in their self-education. And without them having an interdisciplinary or a transdisciplinary point of view, i.e. faculty, then we won't have students who have that way of thinking. That may be a limiting view of this, but that at least is my view. The other thing is that it should probably have the core discipline that is interdisciplinary needs to have its own knowledge base. Now let me give you some examples of this. Here we have art, and here we have history. Now if I'm schooled in history, I don't necessarily have to know anything about art, and vice versa. But if I want to have a core discipline of art history, it has its own specialized knowledge that is the intersection of those two. And we see examples of that in the world because we have journals that are called things like art history. And the core knowledge that's being investigated there is neither history alone nor art alone, but it's the intersection of the two. In the business school, we have a group of people and faculties called International Business. And I give you some of the overlaps here. And it has its own core knowledge, its own core disciplinary ways of thinking about things. There are more, by the way, that overlap. So there's an information systems group. There's an accounting group that also overlap with this. But it was easier to present it with just these three. And lo and behold, they have their own journals. So when you have your own conferences, you have your own journals, you have your own courses in the curriculum, then you have interdisciplinarity going on. And so I'll stop with that and just simply say that we see examples of these core disciplines in the university at present, so I think we do have interdisciplinarity. Now, should we have more? That's a good question. Maybe we should have more, but we certainly see it happening already. But a follow-up question is transdisciplinarity possible? Is it even a good goal? What would it look like? I'm again imagining here, but let's say you had something you wanted to be transdisciplinary and you were going to call it environmental studies. Well, if you look down through the list here, you can see all of the things that a single faculty member or a single student would need to know in order to have complete integration of those. Extremely difficult, right? Maybe you can find a really simple area that only involves 2 or 3 disciplines that you could, in fact, have transdisciplinarity. But I think it's a real challenge to have transdisciplinarity. I mean, it's a nice term. We always like new terms in academia. It forces us to think in new ways. That I'm not sure it's actually feasible except in very, very limited ways. Interdisciplinarity, on the other hand, is something we know, we've seen it, and we should perhaps encourage more of it. Okay? So that's my point of view on this. Thank you very much.
Okay, thank you very much, and as Detmar said, it's been wonderful being here, and it's wonderful the hospitality we've been shown. It's just great. Okay, so I'm talking about something just a little bit different. I'm talking about innovation. So I'm perhaps using the term transdisciplinarity a little bit more loosely in Detmar. But what I'm talking about here is that transdisciplinarity stimulates innovation. This is the argument I'm making. Innovation drives economic growth and improves living conditions, which is pretty well known for how the world moves on, how GDP goes up. And innovation requires creativity, not just problem solving. So by problem solving, I mean the methods we may have learnt in our particular disciplines. So for example, if we're a chemist, we've learned ways of doing chemistry. If we've learned engineering, we've learned problem solving approaches in engineering. But for innovation, we need creativity as well. So the question here is, where does creativity come from? And here we've got someone, very famous person, Steve Jobs. And there's a very strong argument that creativity comes from connecting ideas that exist in the world. So some writers say that the idea that people inventors come up suddenly with some really, really new and stunning idea is what's called the originality myth. So the idea is that we don't particularly have, even very inventive people, have completely original ideas. What we do is we put together ideas that are existing in the world in new ways. And you can see this in history. At some point in time, as technology advances, as the knowledge level goes up, it's possible for creative individuals to put the existing ideas together and come up with something new. And that's why sometimes in history we've had things being invented at almost the same time. So some of the things to do with computers, the graphic user interface and the mouse, these things sort of happened in several different places at once, and people end up arguing about the copyright. So what do we need for creativity? How do we get creative problem solving? So for that we need more disciplines and teams, which means more ideas. We need more creative individuals, which means they have more connections between ideas, and then more connection between ideas give us more creativity and innovation. So unlike Detmar, I'm not thinking that one person necessarily is going to be transdisciplinary, but with teams. If we put teams of people together, then we get these creative things happening. And also that we can help particular individuals to be creative. So, what does a creative individual look like? Now, there are studies of this, psychological studies, and you know, we often say that someone's very clever has more grey matter here. So one famous detective, he says, I solve cases because of my little grey cells. So it's often thought that people who have more grey matter, brain, are cleverer. But what these psychologists are showing that in fact it's not so much the grey matter, it is the white matter that connects up the brain that's important. So they've done studies and measured people who score very high on creativity tests and find that they actually have more connecting white tissue. And so they may have different areas of their brain that they're using for different parts of knowledge, so in some sense they might be transdisciplinary, but they can connect the things up better than the rest of us. And what's more, it's possible to grow that white matter. So we can actually become more creative by going through creative problem-solving exercises and being trained in creativity methods. I hope people believe this. You think so? It's really strange too, because I started out originally as a software engineer. There's been other studies that show if you are a software engineer for any length of time, your brain changes as well. But I don't know if that makes us more creative. The software engineering, I suspect it just makes us more rigorous method type people. So the implications of this is that we really need, in order to have innovation, in order to have society going forward, we really need transdisciplinarity, because we want more people put in teams together so we can get all these ideas together. And we do want to be teaching creative methods. And there are, that's just an example there, but that book, if any of you want to try this with your class, I tried this with the class as an experiment, and it worked quite well. We did some what's called ideation, ways of generating lots of ideas. And who's doing this? There's many places in the world where people are working on transdisciplinary programs. This particular one's in Finland. It's called the Design Factory, and they've got people from arts, design, computing and various other disciplines there together, along with industry. So industry takes a keen interest in this. The building itself, the Design Factory, is outside Helsinki, and it's been set up to especially encourage people to work together creatively. So there's special little areas, there's some sort of up in sort of attic places where you can go and sit and work together. And there's some of the things are a bit funny. One place there's a post, and the post has got a label on it saying hugging post. And if you go by and there's another person there, you're supposed to hug them. So I don't know how many people do this. Would this work in Taiwan? Maybe not. Okay. So what next? I think here in Taiwan, as in Australia, we should be looking to see what's original and different about our own country. We have something very original in Australia that evolved for local conditions, and you can build on those local conditions. So people are now making a bionic kangaroo, which makes use of the special way of gathering energy in the legs that kangaroos have that they've copied now for a robot. So that's the end of my talk. Thank you.